Okay, so I figured I'd make this video just kind of going over the practice free response questions since the check answer button doesn't really work for most of these. And I think that it might help us out a little bit to see some of the answers. So starting off with question 1, the table shows the amount Andre earned as a waiter. Let X represent, or the money in dollars is the amount here. Part A says let X represent the number of hours. Write a linear regression equation. Round the slope and the y-intercept to the nearest whole number. Let's make sure we read about rounding. So whenever we get something with a table and then it's asking us for the regression equation, we want to plot these in Desmos. So I did see one of you guys mentioned this. If you go to this little plus and put in table, it'll automatically put in the x1 and the y1 instead of me doing it manually like I did before. So anyways, we'll put in all of our table, then we'll type in y1 with the tilde mx1 plus b. So if we were to round this to our nearest whole number, the m would be 14 and the b would be 2 because we're rounding to the nearest whole number. So we'd say y equals 14x plus 2. That's rounded to the nearest whole number. B, find the correlation coefficient and then explain what this indicates. So our correlation coefficient is the R, which is 0.997. I'm going to put R equals 0.997. This indicates a strong linear correlation because R is close to 1. It also indicates a positive correlation because R is positive. Remember, R being positive, our data is increasing, and R negative, our data is decreasing. Use the line of best fit to predict the amount earned in dollars after 9 hours. So what we're going to do is we're going to just plug in 9 in for the x because that was a time. So 14 times 9 plus 2. You could do this lots of different ways. You could do it by hand. You do it on Desmos. You could do like 14 times 9 plus 2. Get 128, or you could even do f of x equals. Now we're just going to do 14x plus 2. Normally we would do 14.3571x plus 2.25, but it told us to round our line to the nearest whole number, and then we can do f of 9, we get 128. So lots of different ways to do that. Either way, we get 128. All right, moving on to our next question, question 2. Again, we have a table. Now this time, they don't give us like 0, 1, 2, 3, 4, but instead they give us months. And so we need to make sure that we are very careful about this. And we read that it says, let X represent the number of months since March. Okay, so when we say since March, that means that, March would start off at being 0. March is our 0. So March, would be our 0 and then 950. Then 1 and 858, then 2 and 793. So we'll make this in a table. And then we'll do the whole y1 tilde mx1 plus b to get our regression equation. So this says let x represent the number of months since March. Write a linear regression equation for the data. If it doesn't tell you to round, I would go out as many decimals as you can, but at least to 4. Okay. So 4 decimals here would be negative 77.6786x. So negative 77.6786. And then for our B, it's 944.321. So plus 944.321. So there's our regression equation. Explain what does the linear regression equation for the data represent in the problem situation. So we're just kind of putting this into words. So we would say, the slope would be pounds per month, right? So the amount of chicken feed in the farmer's barn is decreasing by 77.6786 pounds each month. You'd even add like starting at 944.321 pounds if you wanted to. Okay, that in parentheses you don't really need, but we're just basically explaining, the slope in the problem, in the context of the problem. Okay. Next, part C, based on the line of best fit, predict the amount of feed in pounds in December. Okay. Now we want to be careful about December because normally we would think December is 12, but in this case, December is not 12. Okay, so December, right, this is 0, 1, 2, 3, 4, 5, 6. So if we continued, October would be 7, November would be 8, and December would be 9. So we want to be very careful about that. That would be f of 9. So I'm going to start off by doing f of x equals negative 77.6786 x plus 944.321. As well, we could zoom out, to make sure we can see our data. Or you could even, I like it a little better to kind of do, so my x-axis, maybe I'd go from 0 to 10, counting by ones. My y-axis, maybe I go from 950, that's my biggest number. Now, the biggest number goes on the right, actually, since this is decreasing. I'm going to do 480 as my smallest number, and 950 is my biggest number, right? And just don't even worry about counting, and then we can just zoom out a little bit to kind of see this. So there's the data. You just put in your smallest number and your biggest number. Okay. So now we said December would be f of 9. So we get 245.2136. And this question said, predict the amount of feed. It doesn't give us, it doesn't say to the nearest anything. So I'm going to just do the whole number, 245.2136. Right, if it said to the nearest pound, then I would, round that way. But we want to just, if it doesn't ask us, go at least to 4 decimals. That's always, good practice in math. Then it says, based on the line of best fit, predict the amount of feed in pounds in February. So remember, 9 was December, 10 would be January, 11 would be February. So now we'll do f of 11. We get 89.8564. Is the linear regression equation a good indicator of the amount of feed in future months? So if we kind of look at our graph, I would think yes until we get to the 0, right? So, basically, I think this is kind of talking about future months after February, right? February was f of 11. Well, if we look at f of 12, it might work, but then starting at f of 13, it goes negative. So, even though this was a good line, negative 0.993 for R, this data looks very, very linear. It works very well, but after month 12, right, we run out of feed. So in this case, we would say, the linear regression would not be a good indicator for future months, especially after March, right? March was month 12, because the farmer would run out of feed, and you cannot have a negative amount of feed. So this kind of goes into that interpolation versus extrapolation, right? This was very good for interpolation, and even really a little bit of extrapolation. It's good for extrapolation up until month 12, but then afterwards it starts going negative, and so it wouldn't have good data anymore. Moving on to question 3. Question 3 is going to be extra credit. I did post some extra credit videos on the Google Classroom. So, go ahead and watch those if you want to, or you can skip this one. But anything with this, basically necessary condition, confounding variables, those are all extra credit. So question 3 said a common saying is an apple a day keeps the doctor away, meaning the more fruits and vegetables you eat, the less often you get sick. Is eating fruits and vegetables a necessary condition for getting sick? So what we want to think with necessary condition is, basically, did can a person get sick for reasons other than eating fruits and vegetables, right? You can get sick for other reasons, so it's not really necessary. So no, eating fruits and vegetables is not a necessary condition because a person can get sick for reasons other than eating fruits and vegetables. Okay. Then moving on, we have, is eating fruits and vegetables a sufficient condition for not getting sick? Why or why not? So again, no, a person can eat fruits and vegetables and still get sick. Right, you could eat all of your fruits and vegetables, but you could just come into contact with someone else who's sick and then get sick. So, for sufficient condition, we're thinking, can it happen another way? Can you get sick for any reason other than eating fruits and vegetables? Yes, you can. So it's not a sufficient condition. Is there a correlation between eating fruits and vegetables and not getting sick? So I would say yes, there is a correlation, right? Probably people who eat healthier will get sick less often. Right? And then lastly, is it true that eating fruits and vegetables causes a person to not get sick? So I'm going to say no. People who eat fruits and vegetables are often healthier, but people who don't will still get sick. Right? So, or even, but because is it true that eating fruits and vegetables causes a person to get sick? Right? So, if you don't eat them, you still get sick, right? If you do eat them, you're still going to get sick. So we could even say, but people who do and don't eat fruits and vegetables will both still get sick. So it didn't really matter, right? This is kind of an example of maybe a confounding variable. Would be eating fruits and vegetables. It's something that's kind of extraneous. So kind of tricky, but like I said, it'll be extra credit. Okay, next one. Madhur is analyzing the scatter plot below. She determines that the data in this scatter plot has no relation because the x-axis because as the x values increase, the corresponding y values do not increase. Madhur is not correct. There is a pattern here. As the x values increase, the y values are decreasing. So this would be a negative correlation. So it does have a correlation, it just has a negative correlation. So I'll say, no, Madhur is not correct. The data has a negative correlation because as the x values increase, the y values decrease. So what would no correlation look like? It would look like kind of just scattered everywhere up and down, right? There wouldn't really be any pattern. There would be no pattern at all. But this does have a pattern, it has kind of a negative pattern. All right, question 5. We have this graph here, and we have some possible R values. So if we look at this data, it's going up. We could kind of draw a best fit line going up, so that's a positive correlation. This indicates that the R value must also be positive. The data are close to forming I would say it's closer to forming a line than a curve. And so that means R would be positive 0.8. 0.8 is closer to 1. Since we're closer to forming a line, we want a value that's close to close to 1. Right? If it was kind of just scattered everywhere, then we would want something closer to 0. All right, question 6. This one's a little bit tricky, and question 6, 7, and 8 6, 7, and 8 all go together. So just be careful about that. 6, 7, and 8 all go together. So this was our original data set. Okay, so we want to graph that. So I plotted, there we are, 0, 46, 154, 260, 375, 4, 100, and 5, 105. You can kind of zoom to see it better. So I'm going to make my x-axis go from 0 to 5. And then my smallest y value was 46. And my biggest y value was 105. And then I'll just kind of zoom out a little bit, and so that now we can kind of see all of our data clearly. I zoom out even more, and then I can see the x-axis. So there's my data. I already did. Now I didn't do the y1 approximately mx1 plus b. And the reason I didn't do the y1 approximately mx plus b is they said that we're going to use the linear regression equation y equals 12.8x plus 41.33. Now instead of putting y though, in Desmos, I'm going to do f of x because that's going to help me to be able to plug in and kind of plug in a lot of different values. So these are my x values, right? Even says yours in x. So to get the predicted price, I'm going to do f of x. I'm going to do f of 0. F of 0 is 41.33, right? So we'll do 41.33. Then I'll do 46 minus 41.33. So I did, move this over, 46 minus f of 0. You could also just do 41.33, and we got 4.67. And we'll just kind of keep doing this, right? So next we'll do f of 1. We get 54.13. And when we subtract, we get negative 0.13. Right, next we'll do f of 2. Right, f of 2 is 66.93. And we do 60 minus 66.93, we get negative 6.93. All right, I'm going to skip ahead and just kind of fill out the table. All right, and so here's kind of the rest of our data. Again, all I did was just plug in f of 3, f of 4, f of 5, and then subtract. And so we should get these values. Now, question 7 asks us to plot the residual plot. Now, this one's a little tricky because we just have to kind of go back to question 6. I'll make sure on the real test that it's on the same page. But so at 0, we're plotting 4.67. So at 0, we're going to plot, 4.67 is somewhere right there. And it doesn't let us on this one kind of pick an in-between value. So I'm just going to round it to the nearest whole number, which would be 5. Okay. Then at 1, we're plotting negative 0.13. The closest whole number would be just 0. Then at 2, we're plotting negative 6.93. The closest whole number would be negative 7. At 3, we're plotting negative 4.73. The closest whole number would be negative 5. At 4, the closest whole number would be 7, right? 7.4 would round down to 7. And then at 5, we're plotting negative 0.33. The closest whole number would be 0. So if I kind of look at this, there's not really a pattern here. That's something we want to be thinking about with residuals is did it make, oh wait, there is a curve pattern. That's my fault. It does make a curve pattern. Does it? Actually, not really, because it goes down, then up, then back down. If these two would have been flipped, right, if that one would have been there and this guy would have been there, then it would have made kind of a U shape. But because those aren't, it's kind of like if you just played connect the dots, it's going up, down, up, down, up, down. It's not really a pattern. So this is not a curved pattern. So it says the average cost of renting a compact car, increases over a 6-year period. The linear regression was y equals 12.8x plus 41.33. Is a linear model good for your data? So I'm going to kind of look. It looks like my values are very close. This is kind of forming a line. It doesn't really look curved. It doesn't look like it's curving. It's just, our points are on both sides of the line. And it doesn't look like it would make a good curve. We could also kind of cheat a little bit and just add in y1 approximately to get our R value. And we could see that, we get an R value of 0.98, so it's a really high R value. The data looks close to the line. And then also our residual plot was not forming a curved pattern. So all three of those things are going to tell me that a linear model is a good fit. So I'll say yes, a linear model is a good fit because, and then I'm going to just list those three things. One, the R value is very close to 1. 2, the data fits the regression line closely. And 3, the residual plot shows no pattern, right? Remember, we wanted either a flat pattern or no pattern. This was no pattern. It's not giving me a curved pattern at all. Okay, so now moving on to question 9. A study reveals that drivers who wear seatbelts are less likely to experience a severe head injury from an accident. List 2 or more confounding variables that could have an effect on this claim. So again, this will be extra credit. There are lots and lots of different right answers. So a confounding variable would be anything else that might impact it. So maybe, the way the driver was sitting, that could affect it. Maybe, the model of car, right? If you're in like a really small, like car, like a smart car, you might get an injury more than if you were in a really large truck, right? Maybe how fast the driver was going when the accident happened. Maybe kind of where the crash, where the impact occurred. So these are all different things that could have affected, the accident as well, besides the seatbelt. Now, are seatbelts important? Yes, absolutely. But these all could have been important as well. Maybe whether the airbag went off, or even if there was an airbag, right? Some really older cars don't even have airbags. So those are all different confounding variables. And you might have another one, and that one is probably right as well if you think that it affected. So there are lots and lots of different answers here. Right, next up is question 10. And question 9 was extra credit as well. So question 10, again, will also be extra credit. All of these ones that kind of use confounding variables or necessary sufficient conditions, those are extra credit. A class survey showed that students who participated in school government had higher grade point averages. Carl concluded that having a position in school government increased the students' grades. List 2 or more confounding variables. So anything else. So maybe, the students in school government might have studied more. Other options could have been that they may have taken different classes. Right? We could list more. So other things that could have happened could have been that they spent more time in teachers' office hours asking for help. So pretty much anything that you could think of that would be a different reason why would work here. All right, next up, question 11. So again, I graphed this for us. So let's see. There's our graph. So 398, 5189. First step would be to graph this. Okay. Now this part says just on the graph, just go ahead and kind of graph. So 3 at 3, which is in the middle of 2 and 4. I'm going to plot 98. This one is not going to kind of stick. It's just going to go right there. So yours might be a little bit different than mine. I'll still mark it, right? At 5, we're at 189. 189 is going to be below 200. 6, we're at 235. Okay, 235 is going to be above 200. About a quarter of the way up. 8, we're at 309. So just above 300. And then also at 8, we were at 336. So 336, kind of a little bit above that. Then 10, we're at 412. So above 400. 13, we're at 494. 13's in the middle. And then 494 is going to be below 500, just below it. Then 18, we're at 692. So just below 700. All right, so there is our scatter plot. And it says, create a scatter plot, then draw a line of best fit. So to draw the line of best fit, you kind of have to click on 2 lines. So just pick 2 lines that you think maybe E and G might work well. Okay. Or, oops, let's undo that. If you don't think that one works the best, maybe, B and D might work a little bit better. I think that one looks pretty good in between B and D. Potentially in between B and G could work well, right? Actually, it looks like it's just kind of going wherever for us. So we don't even have to actually pick 2 points. We could, on the line, we could just kind of pick, something like that. Just pick anywhere, and, as long as that line kind of looks like it's as close to as many of the points as possible, that works. So you don't actually have to pick points that are already made. You can kind of make your new ones, right? Use Desmos to determine a regression line. So we plot all of our points. I've already done that for us. And then we do y1 approximately m x1 plus b. And it says round your m and your b to 4 decimal places. So 38.3924x. 38.3924x. Then plus 3.6425. I'll round that to 6. So 3.6426. If you put 3.6425 or you even put 3.64258, I'll still give you the credit. Use your regression equation to estimate the number of guitars produced with 23 employees, and then round your answer to the nearest whole number. So I'm going to do f of x equals 38.3924x plus 3.642. I'll go 6 since that's the one that we created. And we'll type in f of 23. So f of 23 gives 886.6. So we'll round that up to 887. So 887 guitars. Then complete our residuals table. So this one takes a little while. So we're going to do f of 3. We get 118.8. It said round to the nearest whole number. So I'll go with 119. And then we'll do 98 minus 119. So we'll do 98 minus 119. You can either do it that way, or you can just do 98 minus 119 like that. And we get negative 21. And we'll just kind of keep doing this, right? Then we'll do f of 5. F of 5, we get 195.6. So I'll round that up to 196. And then 189 minus 196, we end up with negative 7. All right, again, I'm going to skip ahead. Okay, so actually, when I went to skip ahead, I realized I had made a mistake. When I was typing these in, I had accidentally typed this in as 682. And we'll see how this can mess up your whole question if you make a mistake on this table. So I would really highly recommend double checking your tables, 398, 5189. And I realized, hey, 18 was actually at 692. And so that actually changed everything. My B really should have been negative 0.1414. So I would have gotten part B wrong, 0. So it's instead of plus 3, it was minus 0.1414. And then it would have been 38.9596 as the decimal. So my answer for part C was wrong. F of 23 actually would give me 883 guitars. And so then my answers in part D that I started were also wrong. F of 3 would have given us 115. And then we would do 98 minus 115. 15 would have given negative 17. And actually, those answers are still wrong. I made a bunch of mistakes here, so sorry about that, guys, because I forgot to change my f of x. So my f of x is really 38.9596. So f of 23 should have been 896. 896. And then we would get f of 3 is 117 and negative 17. So 117. And then when we do 98 minus 117, we get negative 19. Negative 19. Then f of 5, we'll get 195 if we round that. 195. So 189 minus 195 is negative 6. So again, the reason I made a mistake, and I'll kind of go over this since I did make that mistake, is I had accidentally just mistyped in my 692. So if you mistype in one of these numbers, then all of your regression information is going to get messed up. So this is the correct table. My y1 is approximately, or tilde m x1 plus b, 38.9596 for my m. And then negative 0.1414 for my b. So make sure you have your correct equation. I had this wrong. And so then all of my following answers ended up being wrong because of that. So f of 23, we got 896, right? Then f of 3, we got 117. We subtract that, we get negative 19. F of 5, we'll get 195. We subtract 189 minus 195, we get negative 6, right? And then you can fill out the rest of it on your own. So I will skip ahead and do that for us. And so here is the remainder of our table. So you can go ahead and pause the video and copy that down if you need to, but really you should be able to do that on your own, kind of using Desmos. Right, part E is to create a residuals plot. So we're going to use the x-axis and then the residuals as our y's. So 3 and negative 19. So at 3, we're going to go down to negative 19, somewhere right here. Then at 5, we'll go negative 6. At 6, we'll go to 1. At 8, we'll have negative 3 and 24, both of them. So negative 3 and 24. Then at 10, we'll have 23. At 13, we'll have negative 12. And then at 18, we have negative 9. So again, this isn't really a curved pattern. It's just kind of all over the place. So this would be no pattern, right? This would be no pattern. So is a linear or nonlinear model the best? Well, we look at 3 things. We're going to look at our R value, which is 0.99, very, very good. Then we'll look at the data. So I'm going to just kind of go ahead and rezoom this out. I want it to be going between my smallest x is 3. I'm going to just go 0 to 20, counting by 2s. And then my smallest y is 98 up to 692. Make sure I get those in there. You can zoom out a little bit just to see it all. So this is forming a good line, right? The line is, very close to the data points. And then looking at my residuals, it's no pattern. It's not a curve pattern. So I'm going to say linear model is best because 1, the correlation coefficient R is very close to 1. You can even say like R equals 0.99. It's 0.9965. Then 2, the data points were close to the regression line and were not curved. And then 3, the residual plot had no pattern. Right? If it has no pattern or a flat pattern, those are going to be linear. If it has a curved pattern, that's going to be nonlinear. Right, and then finally question 12. At a restaurant, the total bill and the percentage of the bill left as a tip is represented in the scatter plot. Then they give us the equation y equals negative 0.632x plus 27.1, where x is the bill and y is the percentage as a tip. What does the best fit line estimate for the percentage of the bill as a tip if the bill is $15? So dollars, that's our x. We're going to just plug in 15 in for our x. So we can use Desmos here. We would just make a new one where we don't really need to have the points here. We just want this equation. So instead of y equals, I'm going to do f of x equals negative 0.632x plus 27.1. Right? And so then we'll do f of 15. We're trying to get an estimate for 15. So f of 15 gives us 17.62. So we would do 17.62% for our tip. Explain why this tip is or is not reasonable. Well, if I look at, at 15 looks like it's, that's 12, 14, 16, so 15 somewhere around here. That looks like it's matching up with our data. So I'd say this tip is reasonable as 17.62% looks close to the data and regression line. Also, you could add the word interpolation, right? We're doing interpolation, which usually makes sense with a line. What does the best fit line predict for the bill when the bill is $50? Okay, so f of 50, we got negative 4.5%. We're still going to put that as an answer. It doesn't really make sense to have a negative percentage. And so I'll say, this tip is not reasonable as you cannot tip a negative percentage. And if you wanted to kind of add, this was a very big extrapolation, which sometimes doesn't work, you could add that as well. All right. So anyways, sorry about the confusion on number 11. That does happen. So I'm kind of glad it happened because that way it gives you an idea of how to, correct your answers and what to look for to check and what, to look for when you're checking your work. So again, I would always, check that your data matches the table. And I hope this helps. Good luck studying. I'm not making a video for the multiple choice because on the multiple choice, you have all of the right answers. But if you do have specific questions on the multiple choice, feel free to email me and I can try to help you kind of understand them better.